Now we're going to do some examples from section 4.4. So evaluating trig functions. So we're going to determine the exact values of all the trig functions, sine, cosine, tangent, cosecant, cosecant, secant, and cotangent. Now the first thing to do is recognize that this is simply putting you into a certain quadrant. So the fact that it's positive and negative doesn't make a whole lot of difference. In reality, what you want to do is set up a right triangle in this case. So this 12 means that this length here is 12 and this length here is, well, -5. And the negative is just getting you in that direction. So what I've got is this right triangle, and this is going to be the angle of that we're interested in. And we can use a Pythagorean theorem. Turns out this is a 5, 12, 13 right triangle. And then we can just find the sine, cosine, and tangent of this by simply, well, opposite over hypotenuse. And notice that the negative means that it's going to be in the appropriate quadrant. So we still need to treat that as a -5. And then the adjacent over hypotenuse, and then the opposite over the adjacent. And so that means that then the cosecant in this case would just be the reciprocal. The secant would be the reciprocal, and you get the idea. So once you found the first three, you take the reciprocal to find the other three. So it's not actually that terrible, okay? Same idea here, except in this case, so you're really just building the triangle here, right? You've got, well, this is -1, right? This must be +1, otherwise we don't have the right quadrant. This is our angle, yes. It's our theta, technically, right? This works out to be the square root of 2. 1 squared plus 1 squared is 2, and take the square root. Now, in this case, it's a little bit trickier because the sine of theta would be 1 over the square root of 2. Of course, we can't have an irrational number. We can have an irrational denominator. So we multiply by the square root of 2, so this ends up being the square root of 2 over 2. Does mean the cosecant could just be square root of 2 over 1. Take the reciprocal of this, right, before you rationalize it. Cosine, same thing, except it would be negative 1 over square root of 2. So negative square root 2 over 2. And then the secant would just be -√2. And the tangent would be 1 over -1 or -1. The reciprocal of -1 is -1, so that's actually not that bad either. So it turns out theta is probably pi over 4 here, or, right? If you think about this, this is isosceles right triangle, so that's got to be 45 degrees. Okay, so the point is on the terminal side of the angle in standard position. This is the same thing. So what they're telling you is that you've got something that's going to be down here in quadrant 3, right? And specifically, the x value is -3. The y value is -√7. So then use the Pythagorean theorem, which is 9 plus 7 squared. So 9 is the square root of 16. So this is 4. Okay. So then you can just do the same thing we did in the last problem. The sine would be -√7 over -3, which means the cosecant would be, well, we'd have to take the reciprocal, so that's actually positive, right? Oh, well, that's totally wrong. Let's back that train up there. The sine would be the opposite, -√7 over 4. There we go. So the cosecant would still be negative, but it'd be 4 over √7, or -4√7 over 7 after you rationalize it. Cosine, same idea, adjacent over hypotenuse, so -3/4. So the secant is -4/3. The tangent would be the opposite, -√7 over 3 over -3, so it would be positive √7 over 3. And the cotangent would be the reciprocal of that, or 3√7 over 7. That's it. All right, determine the quadrant. So if tangent is greater than 0, so here's how I like to do that. That means that sine theta over cosine theta has got to be greater than 0, which means they're both positive or both negative, okay? So if you're looking at both positive, that's quadrant 1, or both negative would be quadrant 3. The reason is negative divided by negative is positive, greater than 0, right? So cosecant is 1 over sine, which is less than 0, which means the sine has got to be less than 0. So where's the sine less than 0? That means that this has got to be quadrant 3, because it's and, right? The reason it's quadrant 3 is because there the sine, which is the y value, is going to be negative. So that's the only overlap to these two. All right, theta lies in quadrant 3. So our angle is down here, and we always form our triangle with the x-axis. And the cosine is negative 4/5. So the adjacent, so negative 4 over 5. So if you think about this carefully, you want to find the values of x. I'm using this and this to set up my triangle. And I know that this is negative 3. It's 3, 4, 5, right? Triangle. Reason it's negative, it gets me in the correct quadrant for a negative 4 with a positive 5, and it's make sure it's the right quadrant. So now what we can do is just find the sine. We already know the cosine, tangent, and then do a bunch of reciprocals, right? So this would be negative 3/5, negative 4/5, and then 3/4, and then the cotangent, of course, would be 4/3. The secant would be negative 5/4, and the cosecant would be negative 5/3. All right. So the cosecant is equal to 4, and the cotangent is less than 0. So the cotangent being less than 0 means that the cosine over the sine has got to be less than 0. So positive, negative, meaning they have to be different signs. So the only place where that happens is where you have negative, positive, or positive, negative, right? So we're in either quadrant 2 or quadrant 4, right? And the function value is the cosecant is equal to 4. So the 1 over the sine is equal to 4, right? What does that mean? Well, that means the sine has to be positive. So it sounds like we're in quadrant 2. So we can set up our triangle. The reason we need to know that is so we set up our triangle in the right quadrant. So we're going to set up it in quadrant 2. Now, personally, I mean, we know 1 over sine. So that means that the sine is equal to 1/4, right? So we've already got the cosecant and the sine, right? So the sine is 1/4, which means when we're looking at this, the opposite has got to be 1, and the hypotenuse has got to be 4. 4 squared is 16, minus 1 is 15, so this is the square root of 15, which means that we can find the cosine and then the secant, right? So it's going to be root 15 over 4, which means we take the reciprocal. This is going to be 4 root 15 over 15. And then we take the tangent, which is going to be the opposite over adjacent, which is root 15 over 15, 1 over root 15 rationalized. And then the cotangent, of course, be the adjacent over the opposite reciprocal, right? Would just be the square root of 15. Secant of 0, the quadrant angles. So the secant is 0. So secant is 1 over cosine of 0, right? So what is the cosine of 0? So the cosine of 0 is equal to 1. So that's 1 over 1, which means that the secant of 0 is equal to 1. Done. Reference angle, negative 5 pi over 3. Okay. So now we're going to count by thirds, except we're going negative. So we're going to go in this direction, right? That's negative. So that's going to be 1/3, 2/3, 3/3. So 1/3, 2/3, 3/3. It gets us a full pi. 4/3, 5/3, right? Which means that we are pi over 3 different from here, right? Because 6 pi over 3 would be the full. So the reference angle would be pi over 3. The reference angle is always going to be that acute angle that falls within the first quadrant. There you go. All right, same idea, 10 pi over 3. So 10 pi over 3 means that we're going to go positive, that is counterclockwise, and we're going to go 1 pi, well, 10 thirds, right? So 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3, 9/3, 10/3 is down here. So 10 pi over 3 is down here. So what is this angle here? That would be the reference angle. So theta prime would be pi over 3 again, because that's the difference between these two, 10 pi over 3, 9 pi or 1.5 pi, right? Okay, evaluate sine, cosine, and tangent of this without using a calculator. Well, we happen to know, because we just figured it out, that the reference angle is pi over 3, but we're in quadrant 3. Okay, so sine, cosine, tangent. So for pi over 3, right, we know that what? We know that the sine is root 3 over 2. We know the cosine is 1/2. And we know that the tangent is root 3 over 2 over 1/2, or root 3. Now here's where the fun begins. In quadrant 3, the sine and the cosine both must be negative, but it still means the tangent, negative divided by negative, is going to be positive. So cosecant, secant, and cotangent. So reciprocal of this would be negative 2 root 3 over 3. Reciprocal of this would be negative 2. Reciprocal of this would be root 3 over 3. That's it. So the key thing is knowing the reference angle and remembering your unit circle. All right, almost there. The tangent is negative 5/4. We're in quadrant 4. Find the cosecant. Okay, we're in quadrant 4, so we're over here. Negative 5/4. Opposite over adjacent. Okay, which one would make sense as negative? Well, just this one, right? 4 squared plus 5 squared, so 25 plus 16 is what? Root 41. I don't know if we'll need that. Cosecant is 1 over sine, so we're going to need to take the sine and going to take the reciprocal, so it's going to be the reciprocal. Well, the sine would be the opposite over, so it would be this over this. So the cosecant is going to be what? Root 41, negative root 41 over 5, right? Because the sine would just be opposite over hypotenuse, and we just took the reciprocal. All right. Use the given value in the trig identities to find the remaining of the angle. So cotangent is equal to 5, and sine is greater than 0. So that means we're in either quadrant 1 or quadrant 2. And the cotangent's got to be 5. So that would mean we're looking at what? That would mean that we have, well, we had to be in quadrant 1. The reason being is because that's the only one where both, because remember, cotangent is cosine over sine, right? That would mean that you'd have to have both of these positive or both of these negative. Now, by the way, 5 is the same as 5 over 1. Cotangent is the reciprocal of tangent, so we know that the tangent of theta is going to be 1/5, if that helps, which makes the opposite adjacent, and that makes this the square root of 26, okay? So now we've got the cosine, find the sine and the cosine. So that's going to be 1 over root 26, or root 26 over 26. 5 over root 26, or 5 root 26 over 26. And that means that the cosecant would just be root 26. And the secant would be root 26 over 5. All right, and this is the last one. Cotangent's negative root 3. Cosecant is 2. So 1 over sine is 2. which means that sine has got to be positive, so we're in quadrant 1 or in quadrant 2. And the cotangent is negative, which means that the cosine and sine are different signs, so we must be in quadrant code. Oh, two solutions. Sorry, I'm misreading this. Not the same problem. Let's try that again. Okay. Cotangent is negative root 3. So that would mean that we're looking at the cosine over the sine would be negative root 3. And so that still means that we're either in quadrant 2 or quadrant 4, right? So what angle would that be? Well, to get the root 3, cosine over sine, that means we had the square root of 3 over 2 over 1/2, right? One could be positive, one could be negative. So what angle is as a cosine of that? So that would have to be something related to pi over 6, right? So that means that the cosine has got to equal that, and the sine has got to equal that. So it's going to be something that has a reference angle of pi over 6. So that means we're either looking here, which means that's pi over 6 off of here, which would be 5 pi over 6, just less than pi, or just less than 2 pi, which would be 11 pi over 6. So theta could be either pi over 5 pi over 6 or 11 pi over 6. Cosecant is 2. 1 over the sine has got to be 2. So that means sine has got to be, by extension, equal to 1/2. So where's the sine equal to 1/2? Well, now we're looking at quadrant 2. That's the y value, or sorry, quadrant 1 or quadrant 2, because it's related to the sine. And we have to have 1/2, so that angle would be pi over 3. So one of the answers is pi over 3. What's the other answer? Well, what's the angle that corresponds to pi over 3 here? 3 pi over 3 minus, so 2 pi over 3.